In this video, we're going to be going through how to use the elimination method to solve a system of linear equations. In this case, we're going to be having to multiply both the top equation and the bottom equation by number to get either our x term or our y term to be able to eliminate. When we're trying to get them to eliminate, we're looking for matching opposites. A matching opposite might be like a 3x and a negative 3x, which would allow them to cancel out. Let's take a look at our first example. Here we have 4x plus 3y equals 21 and 5x plus 2y equals 21. Notice here how our 5 and our 4 aren't the same, and our 3 and our 2 aren't the same, and neither of them are opposites. So we need to create that. So we can either choose to get rid of the x's or we can choose to get rid of the y's. It does not matter which one you choose. I'm going to go ahead and get rid of the x's. So my goal here is to make it so that the 4 and the 5 turn into the same number. So I want to know, what does 4 and 5 have in common? Well, they have a 20 in common. In order to make them a 20, I would need to multiply my top equation by a 5 and my bottom equation by a 4. Now, that would only give me a positive 20x and a positive 20x. I need one of those to be negative so that when I add them, they'll cancel each other out. I can do that by either making the 5 negative or the 4 negative. I'm going to go ahead and make the 4 negative. So I'm going to distribute my 5, and that's going to give me a 20x plus 15y equals 105. Then I'm going to distribute my negative 4 again to all three parts to get negative 20x minus 8y equals negative 84. Now I can add those together. My x's will cancel out as we had hoped, and I'm going to be left with a 7y equals 21. From here, I'll divide both sides by 7 to get y equals 3. Now I need to plug my 3 into either my top equation or my bottom equation. It doesn't matter which one I choose, as it will give me the right answer for my x value, no matter which one I choose. I'm going to go ahead and choose my top equation. So I'll be taking the 4x plus 3y equals 21. But I'm going to be replacing that y with the 3 that we just got, which is going to give me a 4x plus 9 equals 21. From there, I'll subtract 9 from both sides, and gives me 4x equals 12. Divide both sides by 4 to get x equals 3. And that's going to give me my ordered pair of 3, 3. Now, it's always important to make sure that you plug those back in to your top and your bottom equations to make sure that it works out and that they're correct. To save us a little bit of time on this video, I've already done that, and my solution is in fact correct. Now, if you need a little bit more help on that, or if you forget how to do that, you can watch the video about, is this ordered pair a solution to my system? And it will be able to show you or remind you how to do that. Let's take a look at our next example. Here we have negative 3x minus 5y equals negative 7 and negative 4x minus 3y equals negative 2. Notice again that our x's don't match and our y's don't match. So the question becomes, what are we going to make cancel out? What are we going to have eliminate? So you get to choose either your x's or your y's. I'm going to go ahead and choose the x's again this time because it's the number 3 and 4, and I find that pretty easy. So I want to know, what can 3 and 4 both turn into? Well, they both have a 12 in common, which means I'd be able to multiply my top equation by a 4 and my bottom equation by a 3. Now that would make them still both negative, so I need one of them to be a negative. I'll make my bottom number negative. It wouldn't have mattered which one I had chosen, I just happened to choose the bottom one. So I'm going to multiply my 4 to all three pieces of my top function to give me a negative 12x minus 20y equals negative 28. Then I'm going to multiply my negative 3 to all three pieces of my bottom equation to get a positive 12x plus 9y equals a positive 6. Then I'm going to go ahead and add those up, and I'm going to see that my 12s, or my x's, are going to cancel out just like we wanted. That's going to leave me with a negative 11y equals negative 22. From here, I'm going to divide both sides by negative 11 to get y equals 2. So now we have to decide where we want to plug in our y value. Again, it doesn't matter if we're choosing the top equation or our bottom equation to plug that into. We just need to make sure that we plug it in so we can find our x value. So I'm going to choose to plug it into the bottom equation this time. So here I have negative 4x minus 3y equals negative 2. And I'm going to take out the y and put in that 2 value. So I now have negative 4x minus 6 equals negative 2. And we're going to solve for x. We'll do that by adding 6 to both sides, and then dividing both sides by negative 4, which gives us a negative 1. So we'll have an ordered pair of negative 1, comma 2. And again, when we plug that in to check it, we're going to see that that does work. But it is important to make sure that you are checking your solutions. I'd like you to do letter C on your own. So go ahead and push pause, and when you're done, push play, and we'll see if you're right. So here we have 8x plus 4y equals 12, and 7x plus 3y equals 10. I don't have any matching opposites yet, and if I look, what does 8 and 7 both have in common? And the answer to that is 56. That's a pretty big number. But if I look at the 4 and the 3 at my y's, theirs is a 12. So I think I'd rather work with smaller numbers, so I'm going to choose to have my y's become the matching opposites to eliminate, which means that I'm going to multiply my top equation by a 3, because 3 times 4 is 12. I'm going to multiply my bottom equation by a 4, because 4 times 3 is 12. They're both going to end up being positive, so I need one of them to be negative. Again, I can make my 3 the negative or the 4 the negative. It doesn't matter. I'm a fan of making the bottom equation the negative, so I'm going to do that. So I'm going to distribute my 3 to all three pieces, and I'm going to get 24x plus 12y equals 36. Now on the bottom, I'm going to distribute my negative 4 to all three pieces, and I'm going to get a negative 24x minus 12y. Sorry, that should be a 28 right there. Just trying to go so fast. A negative 28x minus 12y equals a negative 40. And from here, we can go ahead and we can add those. So we're going to get negative 4x. Our y's are going to cancel out just like we planned, and we're going to end up with a negative 4. So we'll solve for x by dividing by negative 4, which will give us x equals a 1. So now we have to decide which equation we're going to plug our 1 into. Are we going to choose the top equation, or are we going to choose the bottom equation? It doesn't matter which one we choose, as it will give us the correct y value either way. So I'm going to go ahead and I'm going to choose the bottom equation. And I'm going to take out my x, and I'm going to be replacing my x with the number 1 that we just got, which gives me 7 plus 3y equals 10. And now we're going to solve for y. So we're going to get the y by itself. We're going to do that by subtracting 7 from both sides, then dividing by 3, and seeing that y equals 1. So here, that's going to give us an ordered pair of 1, comma 1. And when we plug that back in to check, we're going to see that that does come out as correct. So here we have ordered pairs of 1, comma 1. So here are 3 examples of how to use the elimination method to solve the system of linear systems when you have to multiply both your top equation and your bottom equation by a number in order to make the elimination happen.